Hello everyone, welcome to our class. My name is Ko-Chen Lee. In today's sections, we will talk about the computer hardware installation. Before we show you how to build your own computer, we need to prepare assembly of hardware parts and tools. Parts we need, except for the case with power supplies. The necessary parts are CPU, RAM, motherboard, video cards, and the hard drive. The first one, Central Processing Unit, CPU for short. Different CPU types include solo, dual, quad, etc. They indicate number of processing units in a chip. So, the higher the number of the core is, the better efficiency the computer works. And of course, it's more expensive. The next is CPU fan. It is important, mainly reduce the heat generated by the CPU operations. If the CPU is overheated, it will cause the machine breakdown and won't be function correctly. That's why we need to cool down the CPU. The third is the random access memory. RAM for short. RAM has different sizes to choose, ranging from 1G, 2G, 4G, etc., depending on your need. The bigger the memory size is, the better efficiency the computer operates. Remember what we have mentioned in the previous sections. All the programs need to load to the memory before they execute. The fourth is the motherboard. It has some well-known brands, including Intel, AMD, Asus, etc. Motherboard must fit to the corresponding CPU because of the different type of interface for various CPUs. When choosing a motherboard, we need to consider CPU types, memory slots, VGA interface, bus interface to fit all your components. The fifth is the Video Graphic Array Card, VGA card. We can group VGA cards by the interfaces, such PCI, AGP, and so on. Some motherboards have graphic cards built in. However, if the user wants to run the 3D graphics or make multimedia, an external graphic card is necessary. The sixth is the hard disk drive, HDD, or the solid state drive, SSD, for today's newest technology. The amount of capacity mainly depends on the needs of individuals. Currently, two main kinds of hard drives in the market are HDD and SSD. The bus interfaces are valid too. They are IDE, Serial ATA, Serial ATA2, Serial ATA3, etc. Other than the necessary parts, some optional parts we can have. The digital versatile disk read-only memory, DVD-ROM. Nowadays, few people use pure CD-ROM. Capacity and functionalities according to the needs of individuals decided. So most people use a DVD-ROM containing burning capabilities. Types of DVD-ROM can be divided into the pure DVD-ROM, DVD burners, and the Blu-rays, etc. The eighth is the power supply unit. it offers various parts of the power supply. The power supply must be in accordance with the parts of your computer to choose a different wattage. The next is the bus cables. They are used to connect all your components to motherboard and let them communicate with each other. The last one is the case. Different sizes to choose from, depending on your needs. Now we can start to build our computer. First, the CPU, the most important part of the computer. It is like the heart to a human. The picture shows the top view of the CPU. As we mentioned before, different types of CPU may have different interfaces. We have to be very careful to match the right motherboard to the selected CPU. To install a CPU, step 1. We need to open the secure cover of CPU on the motherboard. Look at the pictures. After we open the secure cover, we can see a socket where we should install the CPU to. Most CPUs contain more than 100 pins. So to install the CPU, we have to be gentle and make sure each pin goes to the correct slot and ties to the socket. And the secure cover helps to lock the CPU in the right position. After we open the secure cover, then we can install the CPU onto the socket. In this step, putting the CPU to the correct direction is the most important thing. Most CPUs have foolproof design to help us get the right direction. The only thing we need to do is to match the designed marks or shapes. Look at these pictures. The CPU has 2 corners to match to the socket. Now we are ready to put CPU onto the slot platform. Just carefully match the corners and the marks on both CPU and the motherboard. Install the CPU horizontally to the sockets until the CPU evenly tied to the socket surface. We can check if it is tightly installed by pushing each corner. The final check to see if the CPU is installed appropriately. We have to make sure this step does not go wrong. If we did not install CPU correctly, not only the computer would not operate properly, but also CPU and motherboard will be damaged and won't be able to fix. So, double check to identify that CPU is installed appropriately. Once we make sure the CPU is installed correctly, then we can close the secure cover, which can help tighten the CPU to the socket. Peel off the plastic slice to expose the top of CPU for the later-on installations. Then we can lock the secure cover by turning the secure bar. And the CPU installation is complete. The picture shows that CPU is locked onto the slot platform. The top of the CPU is exposed to transmit heat to the fans that we will install later on. Again, different types of CPU have different interfaces, but the principles are the same. Just read the menu and follow the steps, and you can install CPU correctly. The actual installation of the memory module does not normally require any tools. RAM is installed in a series of slots on the motherboard known as the memory bank. The memory module is notched at one end, so you won't be able to insert it in the wrong direction. For SIMMs and some DIMMs, you install the modules by pressing it in the slot at approximately a 45-degree angle. Then push it forward until it is perpendicular to the motherboard, and the small metal clips at each end snap into place. If the clips does not catch properly, check to make sure the notch is at the right end and the card is firmly seated. Many DIMMs do not have metal clips. They rely on frictions to hold them in place. Again, just make sure the module is firmly seated in the slot. Most of the motherboards in computers have 2 or 4 RAM memory slots. Most RAM slots are located on the top of the motherboard, on the right-hand side. Some computers support dual-channel RAM configuration either as an option or as a requirement. Dual channels means that RAM modules are installed in matched pairs. So if there is a 512 megabyte RAM card installed, and there is another 512 megabyte card installed next to it, make sure the retainer clips for the RAM are all the way open, and place the RAM in the slot and gently push it straight down with your thumb. And you may have to press hard to set the RAM correctly. When you press down hard enough, the retaining clips on either side of the RAM will snap into place, making a clicking sound. The picture shows the complete installation of RAM. An important thing to realize is that your options of choosing the RAM will depend on the design of your computer. Most computers sold today for normal home office use have DIMM slots. High-end systems are moving to RAM technology, which will eventually take over in standard desktop computers as well. Since DIMM and RAM slots look a lot alike, be very careful to make sure you know which type your computer uses. Putting the wrong type of card in a slot can cause damage to your system and ruin the card. The CPU tends to heat up when being used. The CPU tends to melt or break down when the heat produced is not dissipated. The CPU fan cools the computer's processors and prevents it from breaking down. For better cooling functions, the CPU fan is installed with a heatsink. A heatsink is a metallic device that attaches directly to the CPU, drawing away the heat of the CPU through its aluminum fin-like structures. CPU fans, along with heatsinks, come in a wide variety of designs and sizes. Most new processors come with their own CPU fans and heatsink. What we need to prepare are cooling fan, thermal grease, and a small scraper. The next step is to smell thermal grease onto the cooling fans. That helps to transmit heat to the heatsink. Affix the CPU fan to its heatsink. This may have already been done. If the fan has not been attached, carefully fasten the fans and the heatsink together by using the screws that came with the devices. Attach the heatsink and fan to the CPU. The method of attaching the heatsink and fan to your CPU differs for CPU fans, and heatsink. A thin layer of heatsink compound may be spread on the CPU's surface to ensure contact. Some fans and heatsinks attach to the CPU chip with a number of clips. Attach the fan gently with an even amount of force. Make sure not to damage the CPU and the motherboard of the computer. Connecting the power cable of the heatsink and fan combinations to the 3-pin power LED found on the computer's motherboard. Searching for a label fan or CPU fan. The picture shows the complete of CPU fan. Many cheaper CPU coolers have just a rubbery stick-on pad on the bottom, not grease. Thermal pads work better than a dry joint, but not as well as a greased one. You can hook up these coolers by scraping the pad off and replacing it with an appropriate smell or of heatsink grease. Better coolers these days come with a pre-applied semi-solid thermal groups pre-applied, which gives you the best of both worlds. The first step will be to open the case. The method for doing this will vary depending upon the case you have. For mid-towers, you will most likely have to remove a side panel that sits above where the motherboard will be. Most new cases have either a side panel or doors, while older ones require the whole cover be removed. Remove any screws that hold the cover to the case and set it aside in a safe place. While there is a standard ATX connector design for the back of the motherboard, each manufacturer can lay out the connectors however they need to. This means that the basic ATX connector faceplate will need to be removed from the case, and the custom one that shipped with the motherboard be installed. To remove the basic ATX plate, gently placing one on the corners of the installed ATX plate until it pops out. Repeat this on the opposite corners to fully remove the plate. Install the new ATX plates by aligning the connectors properly and gently pressing from the sides until it snaps into place. There are a variety of sizes that a desktop motherboard can come in. In each case, there is a series of mounting holes that need to be lined up between the motherboards and the case-out tray. Compare the motherboard to the tray that is going to be installed in. Any locations that has a mounting hole will require a standoff installed in the tray. Lay the motherboard over the tray and align the board so all the standoffs are visible through the mounting holes. Starting with the centermost mounting point, insert the screws to fix the motherboard to the tray. After the center, working in a star pattern to affix the corners of the board. The picture shows the complete of motherboard installation. Many motherboards today have a variety of additional connectors for different types of parts that do not fit on the motherboard's ADX connector plate. To handle this, they supply additional headers that connect to the motherboard and reside in a car slot cover. Additionally, some of these connectors may reside on the case and can be connected into the motherboard. The internal hard disk connect to your computer's motherboard using an IDE interface or serial ATA interface. Most new hard drives come with either an IDE or a serial ATA connection cable, depending on the type of drive. Many internal hard drives contain jumper pins that you must set to designate a hard disk as a primary disk or as a secondary disk. These jumpers are small plastic slivers that you must press on the correct metal jumper pins. For additional instructions, check the information that came with the internal hard disk. Here is a picture of a hard drive installed in the case. Simply screw in the drive to secure it in the case. When you have the power plug in, it is time to make sure your system accepts your new drive. If you look at the rear side of your CD, DVD-ROM, on the right-hand side, you have the power connector. Next to the power connectors, you have the IDE connectors. On the left-hand side near the IDE connector, you have the jump settings for the DVD-ROM. The jumper is set to master by default. If you are connecting the DVD-ROM on a separate IDE cable, therefore, you can leave the jumper setting to master. However, if you are sharing an IDE cable with another device like HDD, then you will have to set jumper to slave, as your HDD would be set to master. Next to the jumpers, you have the CD audio out socket. One side of your audio cable connects to this socket, and the other side connects to the sound card CD in socket. This will allow you to listen to audio CDs on your computer. Mount your CD DVD-ROM drive into its mounting slots. Use the supply screws to screw the drive into position. The final step is to connect the IDE cable to the drives. IDE connectors, which we will show you in the later sections. And the graphic cards or video cards, as it is also known, allows your computer to display thousands of colors and images to your display. Some computers have a graphic card built in to motherboards. These are usually low-spec cards and normally use RAM from your system to run. As PC programs continue to get more complex, we need a bigger, more powerful graphic card to push all those pixels. The latest cards from ATI and NVIDIA deliver nearly cinematic effects. To install the VGA card, simply plug graphic card into a PCI Express or AGP slot. Do this gently, but make sure the card is firmly slotted in. When your graphic card is in place, some cards require you to screw it in. Check the documentation that you got with the card if you are unsure about this. And the picture shows the complete of the VGA card installations. Nowadays, like a motherboard, some graphic cards house the processors and RAM. It also has an input-output system, BIOS chip, which stores the card's setting and performs diagnostic on the memory. Input and output at startup. A graphic card's processors called a graphic processing unit, GPU. It's similar to computer CPU. A GPU, however, is designed specifically for performing the complex mathematical and geometric calculations that are necessary for graphic rendering. This is for today's sections. Thank you for your listening.